Hey guys, today we're doing Chapter 4, Section 6, which is an introduction into sine, cosine, and tangent functions. So in this section, basically what we're going to learn about is how to graph sine, cosine, and tangent functions, what they look like graphically, and this is really important because you guys are going to have to know how to graph all of these without a calculator at all. You have to memorize these graphs, okay? You need to know how to graph these just in your head, okay? And it's really important because we're going to be learning how to shift these around. We're going to learn how to stretch them and shrink them using scale changes and translations. So you have to know what the original graph looks like. That's why I don't want you, using a calculator or anything to graph these. You just have to know what they look like. So my sine function, well, what I'm going to do is I'm just going to show you how to find it on the calculator. That way you always have access to what they actually look like. And then I'm just going to sketch the graphs up here. So on the calculator, what we want to do is we want to change our window from -2 pi to pi for our x values. Or I'm sorry, -2 pi to 2 pi. And then for our y values, I'm just going to change it from -2 to 2. And I'm going to make sure that I'm in radian mode because we want all of our graphs in radians. And then I'm going to enter in sine of x. So this is what my graph looks like. And transferring that over to a sketch, I've got, pi, 2 pi, here's -pi, and -2 pi. I'm going up to 1, 2, -1, -2. So I go through the origin, I go through pi, I go through 2 pi, -pi, and -2 pi. At pi over 2, I'm at +1. At 3 pi over 2, I'm at -1. Okay, here at -pi over 2, I'm at -1. And at -3 pi over 2, I'm at +1. And you can calculate all those out using your unit circle. You don't really need to memorize those or anything. Those are all just part of that unit circle where you've got 1, 0, 0, 1, -1, 0, and 0, -1. Then what I'm going to do is just sketch in my curve. And this is my sine function. Okay, cosine is the same way. If I graph it on my calculator, you can see it looks pretty much the same. The only difference is that instead of going through the origin, now I'm going through the maximum. So over here, I'm going to have the same graph. So I've got pi, 2 pi, -pi, -2 pi, 1, 2, -1, -2. Okay, I'm starting at my maximum here. At pi, I'm at my minimum, and at 2 pi, I'm at my maximum again. Same thing over here. So then, halfway between each of these, I'm at my x-axis. I'm going to sketch my line in. Okay, there's my graph. So you'll notice that the sine and cosine function look pretty much the same. The only difference is that this one goes through the origin, this one starts at the maximum. For these functions, I think that in general you at least want to graph from 0 to 2 pi because that's one actual cycle of the function. Same here, if you just go from 0 to 2 pi, that's fine. I just went from -2 pi to 2 pi to give you guys 2 cycles. You should notice that the minimum values are always -1. So that's the minimum of your function. The maximum of your function is 1, and that's true for both of these. Okay, so the domain of sine and cosine is going to be all real numbers, whereas the range is just from -1 to 1. Okay, now your tangent function is a little bit trickier. So I'll just show you how to graph it on here. And I'm just going to change my window. Actually, I'm not going to change my window. I'm just going to hold it up. So this is what my graph looks like. And you're probably like, whoa, that looks crazy. It's really not quite that bad. And I'll just go through and explain it a little bit. So I'm just going to go, I'm going to call this pi over 2. and I'm going to call this pi, just because I don't want to have too much going on here. And then I'm going to go from negative pi over 2 and negative pi right here. Now, in a tangent graph, we're undefined at pi over 2, and we're also undefined at 3 pi over 2, which is also the same thing as negative pi over 2. So each of these are places where my function is undefined. Or any odd multiple of pi over 2 is a place where my function is undefined. So again, up here at 3 pi over 2, that would also be a line where it's undefined. So those are called asymptotes because I cannot actually have something for pi over 2 because it's undefined. So that's an asymptote. It's a place where my function is approaching, but it's never actually going to reach. So my tangent function essentially starts at 0, and in this direction it goes up this way, okay, approaching this line. It's never actually going to hit it, okay, and in this direction it goes the other way, okay. So this is what your tangent function looks like. It's just this over and over again, okay, where each of these odd multiples of pi over 2 are asymptotes. Alright, so these are called circular functions because their definitions are based on a circle. As a result, they repeat themselves at regular intervals, making them called periodic functions. The value of the smallest possible real number p for which the function repeats itself is called the period of the function. So in other words, before I actually start repeating myself, the smallest amount of time where that occurs is called the period. So if I go back up here, and I think about the period for the sine function, well, if I'm starting at negative 2 pi and I'm at 0 here, and I go up and then down and come back to this 0 mark, it's taken me 2 pi to repeat myself. So I've had to go all the way around the circle, right? 2 pi is 360 degrees. So that's how long it takes me to repeat myself. So the period of this function is going to be 2 pi. Okay, so what is the period of sine, cosine, tangent? For sine, the period is 2 pi. For cosine, the period is 2 pi. And for tangent, if I look at my tangent graph, I'm going from asymptote to asymptote. So if I go from negative pi over 2 to pi over 2, that's a total of pi. So the period for tangent is pi. That leads us to our periodicity theorem, which says that for any theta in any integer n, if I take the sine of theta plus 2 pi n, aka any multiple of 2 pi, I get sine theta. So in other words, if I start at my 0 mark on the circle, and I go all the way around, I'm back to 2 pi, then I go all the way around, I'm at 4 pi, well, those are the same spot on the circle, so they're going to give you the same value. But it's the same thing for 0, 2 pi, 4 pi, 6 pi, all of those are the same thing on the circle. So if I plug those into my sine function, and I add some sort of multiple of 2 pi, it doesn't change anything. It just gives you the sine back out. And the same thing goes for cosine, and then tangent, it happens every pi because the period of tangent is pi. Alright, that is everything for section 6.